Second example is ester. Second example is we are taken as ester, hydrogen, air chlorine. Okay, this is a target molecule. Second example, when it is undergo function group interconversion, esters are converted into alcohols. Esters are converted into alcohols. Esters are converted into alcohols, and these alcohols undergo function group interconversion. Then again ester. Cl. Now it is undergo again function group interconversion. Then ester is that. Okay. Now we are going to synthesize this molecule, target molecule from that is now ester. When this ester was synthesized from here, when this ester reaction with HCl undergo Michael addition, chlorine and hydrogen here, then double bond O ion ester, then alpha beta addition reaction. When it is reacting with lithium aluminum hydride, these esters are converted into alcohols. Esters are converted to alcohols. These alcohols are when reacting with benzoyl chloride, loss of HCl, then the product is our target molecule. Then the product is our target molecule. Okay. So next, here we are going to synthesis of primary amines. Synthesis of primary amines. When synthesis of primary amines from beta phenyl ethyl amine. This is beta phenyl ethyl amine. When this beta phenyl ethyl amine undergo this target molecule, when this beta phenyl ethyl amine undergo converted into cyano. When this cyano is converted into, so this benzyl halide. When this benzyl halides, synthesis is benzyl halides when reacting with HCN, loss of HX, then forms benzyl nitrile. When this benzyl nitrile undergo reduction with lithium aluminum hydride, cyanides are converted into amines. The target molecules were synthesized. Okay. Next one is, so next one synthesis of secondary amines. Synthesis of secondary amines. When secondary amines undergo functional group interconversion, that function group interconversion, amines, secondary amines, function group interconversion, the secondary amine undergo function group interconversion, amines are the product. This amines undergo converted into carbonyl compounds. Now synthesis of this secondary amine target molecule from carbonyl compounds. When the carbonyl compounds reacting with primary amines, in presence of acid medium by loss of water molecule, amines are the products. This amines under reaction with the lithium aluminum hydride reduction, then products are secondary amines are the products. This is one example for synthesis of secondary amine. Next one is So next example is we are going to discussing. So same, all secondary amines are synthesized. Listen me, all the secondary amines are synthesized from imines, and imines are obtained from carbonyl compounds. All the secondary amines are synthesized from imines. These imines are formation with the reaction with carbonyl compounds and primary amines. So that's the one example. And here, next one is synthesis of tertiary amines. Have taken piperidine derivative, N-heptyl piperidine, N-heptyl piperidine, N-heptyl piperidine. When this N-heptyl piperidine undergo function group interconversion, here 5 and here methyl. When this compound N-heptyl piperidine, then amides are the products. These amides under hydrolysis, the products are secondary amines. Okay, now synthesis of this N-heptyl piperidine from secondary amine. Then secondary amine reacting with N-heptanoyl chloride. N-heptanoyl chloride reacting with N-heptanoyl chloride. When this N-heptanoyl chloride by loss of HCl, N-heptanoyl chloride, here methane is the product. This N-heptanoyl chloride when reacting with lithium aluminum hydride, N-heptanoyl chloride when reacting with lithium aluminum, when reacting with the hydrogen catalyst, that keto is converted into amides. It is converted to amines. Okay, this is the synthesis of amines, different amines, primary, secondary, tertiary amines. So we are synthesized in the pathway. Next one is convergent and consequent and convergent synthesis. Consequent and convergent synthesis. This is important. In discussing consecutive synthesis. Consecutive synthesis. In this consecutive synthesis, the target molecule is made up of sequential arrangement of different intermediates. Okay, the target molecule is made up of sequential arrangement of intermediates. Okay, we have this target molecule is synthesized from F. This F is synthesized from E, and the E intermediate obtained from D, and D is from C, C is from B, B is from A. Okay, A from starting material. Okay, the sequentially arrangement of intermediates we are getting target molecule is consequent synthesis. When we go into discussing in convergent synthesis, in case of convergent synthesis, the target for the synthesis of in the target molecule, we have to synthesize the starting materials separately. We have synthesized starting materials separately. I'm going to here. This is A intermediate and B intermediate. Okay, this A intermediate obtained from, we are going to X and Y, and here B intermediate obtained from 1 and 2. Okay, when X and Y when the X and Y reactant then forms A intermediate, and 1 and 2 react, they forms B intermediate, and these two when these two intermediates are A and B intermediates are coupled, then forms our target molecule in convergent synthesis. In this convergent synthesis, the target molecules are synthesized separately. The intermediates are synthesized separately. They are step that is called convergent synthesis. In consequent synthesis, each intermediate made up of Then from each intermediate sequence arrangement, they gives target molecule in consequence synthesis. In convergent synthesis, so in the convergent synthesis, the half of the molecule synthesized from one path and half of the molecule synthesized another part, and this half of the molecules are coupled, then gives our target molecule. Okay, this is a convergent synthesis and consequence. This is a linear synthesis. Consequence is also name is linear synthesis. Okay, so the target linear synthesis, that means each intermediate sequence arrangeable, then arranged each intermediate sequentially we are getting arranged, then forms target molecule. Therefore linear synthesis. This is a branched synthesis. This is branched synthesis. Okay, branched synthesis means we are synthesized the intermediate separately, then we are coupled, then forms target molecule. There's a convergent synthesis. We are going to discussing our one example here. We are going to discussing one example for each one is each one. So I'm taking this is a target molecule. I'm taking this is a target molecule, cyclohexane. This is phenyl N and here OH. This is a target molecule. This target molecule we are going to synthesize in two ways. One is linear method, another one is non-linear method or convergent synthesis. Okay, this is we are going to discussing in two paths. We are going to discussing two paths. One is consequent synthesis and convergent synthesis, linear synthesis and branching synthesis. First we are going to synthesis linear synthesis. We are going to discussing linear synthesis. Then it is undergo. First one is Grignard transform. Grignard transform. This is a paper 6 unit 15. Paper 6 unit 50. Okay, so this Grignard transform. When this Grignard transform, alcohols are converted into carbonyl compounds. Alcohols are converted into carbonyl compounds, and this is that this phenyl group is eliminated. Okay, then forms piperidine ring. Okay, when it is undergo managed transform. When it is undergo managed transform, then managed transform, here bond will be broken, then forms CH3 C double bond O. This is that managed transform. Okay, this is managed transform. So one managed transform. So a mistake is there here. This is a ring is there in your book. One printing mistake is there. This is a mistake, and it is undergo Friedel-Crafts transform, benzene and SL chloride. So now synthesis of this target molecule from benzene and SL chloride undergo AlCl3 Friedel-Crafts transform. Acetophenone is the product. When this acetophenone reacting with formaldehyde, HCl and piperidine. Formaldehyde, HCl and piperidine undergo managed transform. Then amino-methylation takes place. It is a managed reaction. When this compound undergo reacting with phenyl magnesium halide, that addition it carbonyl compound, then carbonyl compound convert to alcohols. This is a path. Okay, this is a linear synthesis. Okay, when we are going to discuss it, this is a convergent synthesis. This is I am explaining with in convergent synthesis. I'm explaining convergent synthesis. In convergent synthesis, This is a target molecule in convergent synthesis. Convergent synthesis. So here bond is broken here, then forms ketone and phenyl, benzophenone. When this benzophenone is obtained from benzene and benzoyl chloride. Plus here magnesium halide minus. That's the product. When it is undergo piperidine plus epoxide is the product. Okay, so we are in convergent synthesis. Already I'm telling you. So half of the molecules are synthesized in separate way. Half of the molecules are synthesized in separate way. These two intermediates are combined, then product formation takes place. I'm here. I'm explaining here when this here benzene when reacting with benzoyl chloride undergo AlCl3 Friedel-Crafts acylation. Benzophenone is the product. This is a benzophenone. When piperidine reacting with epoxide in presence of Lewis acid PCl5, then opening the ring, then here forms chlorine. Okay, when these two intermediate, this intermediate A, intermediate B, we are coupled together in presence of magnesium dry ether, then the target molecule was synthesized. The target molecule was synthesized. Okay, this is the convergent synthesis. Okay. Next one is one. Another example is disperser. Another example is disperser. Disparler. Sorry, disparler. Disparler. This we are important. This is a very important. Here two compounds are there. Disparler and jasmine. These two compounds we are expected in exam. Compulsory one question we are expected from these two. Any one of we are getting. First we are going to about this is a compound. When this compound here hydrogen. This is a compound. This is a compound. When this compound epoxide, this is a compound. This is a disperser is a compound. When this compound undergo epoxide transform, epoxide will be elimination, and olefins are the products. And then this is the product. When this compound undergo Wittig transform, the bond will be broken here. Then if Wittig transform, then that is triphenyl phosphine hydrogen plus carbonyl compound. This is a product. Okay, so this is a product. When we are going to synthesize this disparler from this triphenyl phosphine component and aldehyde carbonyl compounds, then here this is obtained from when this here simply we have substituted a halogen. Okay, now synthesis of this target molecule is from halo compound and reacting with triphenyl phosphine displace the halogen when this compound reacting with aldehyde, reacting with aldehyde here in presence of base in presence of base by loss of triphenyl phosphine double bond verb, then double bond will be formation takes place. Sorry, okay, then double bond will be formation takes place between these two carbons. Then when it is reacting with metachloroperbenzoic acid, double bond undergo epoxidation. Epoxidation. This is the plus dispersal is the synthesis. Okay, so next we are going to jet jasmine. Jet jasmine. Okay, we are going to synthesize the jet jasmine. Now, retrosynthesis. Now, first we are going to discussing retrosynthetic analysis. Methyl. Okay, when this compound undergo so breaking of double bond, functional group interconversion, methyl double bond work. Okay, now it is undergo. Now it is undergo. So when reacting with now two ketos are protecting. Two ketos are protecting. Then this is a product and one methyl. When it is again halo double bond methyl is when it is again functional group interconversion, then the product is this is the product. Okay, when it is this dihalo compound undergo here the bonding cleavage like this, then forms and furan derivatives like plus 1,2-diethane materials to synthesis of jet jasmine. In the synthesis, now we are going to synthesis of jet jasmine. When ketol of this alcohol, when reacting with 1,2-diethane, when reacting with 1,2-diethane, in presence of acid medium. 1,2-diethane in presence of acid medium. Then SS, here SS is a product. Here hydrogen, here hydrogen. Now this compound when reacting to N-butyl lithium, base subtract the proton from here, any one here, base subtract the proton from here, negative charge, SS. And this negative charge is reacting with reacting with our another starting material is CH3. When this compound, this halogen is replaced, then forms. I am writing here. Both positions are same, but I am writing here methyl SS is a product. When this compound again reacting to N-butyl lithium, in presence of THF. Second one is reacting to methyl halide. So base subtract the proton and methylation takes place at this position. Then here methyl. Okay. When this compound reacting with MgCl2, cadmium carbonate and water molecule undergo deprotection of ketones, dithials, then forms ketones are the products. So when this compound it is involves reacting with base intramolecular aldol condensation and forms alpha beta unsaturated carbonyl compound, then that is Z-jasmone is the product. Okay, here today that whatever we are discussing, one is convergent synthesis and consequent synthesis. These two are very important, very important. Whatever we are discussing, convergent and consequent synthesis, and we are discussing plus dispeller and Z-jasmone. These two are important. Okay, expected question from this unit is these 4 questions are we are compulsory expected in this exam, in your exam paper. Among these 4, one is compulsory in your question. What is convergence is consequent and plus disperser and plus Z-jasmone is the very important questions. Okay, thank you, students. Definitely, I will send you a PDF notes within 2 days.